Okay, so I'm Talia. I did a talk yesterday. I'm glad I didn't scare you guys away with my testing and production talk. Today we're going to talk about something different. We're going to be talking about building applications with infrastructure as code. This is my background. If you missed me yesterday, I used to be a test engineer. I started my career doing QA and automation, and then I transitioned into being a dev advocate and doing more work with external developers. Yeah, and before Akamai, I was at AWS. I was on the serverless team, and now I'm at Akamai doing a lot of cloud-focused content with Linode. So let's get started. All right, so we're going to go through an introduction to infrastructure as code, talk about what it is, what the use cases are, and why someone would want to use infrastructure as code. We'll talk about some of the benefits, then we'll talk about some of the tools. Specifically, we'll go through a demo with Linode and Terraform at the end, and why you'll want to use specific tools, one versus the other. Okay, so many times when developers start building applications, you usually start in your cloud provider's console, right? Like you'll go into like the AWS management console or whatever cloud provider you use, and you choose like create a Lambda function here, choose this resource here, make this a destination for this Lambda function here, create this database from the UI. Like normally, especially like when I first started in the cloud, like the first thing you do is you go to the UI and you play around with it and build stuff because you have this graphical interface, like this place that you can see everything and how it's connected. But the only problem with using a UI like that is that what happens when you want to copy everything that you did to another account, or if you want to use this in, I hate to say it, a staging environment, or if you want to use it somewhere else that is not where you originally created it. Like, how do you replicate what you just did? Like, chances are you're not going to remember the exact resources, the exact configurations, what specifically connected to what. And so that brings us to infrastructure as code. And this kind of solves that problem of that automation, that replication of how do I replicate what I just did? How do I remember all the configurations? So that's kind of what infrastructure as code does for us. So with infrastructure as code, what you're doing is you're automating that provisioning process. So you're not going to go to the console and click on the services you want and configure the resources from the console. What you do is you have what's called a configuration file. And in this configuration file, you define all of the resources that you want for your application and all the configurations for those resources. And that tells you how to instantiate your infrastructure. So you're not doing this from the UI, you're doing it from a configuration file. And so in this configuration file, you have one place with all the steps to set up your application, and you can reuse this whenever you need. And what this does at the core of this is it allows you to treat your configuration file, treat your infrastructure as code. And so what do you do with code if like something doesn't work? If you push something and it doesn't work, you roll it back to a different version, right? So you have this one place that has like a consistent view of your application. And if something goes wrong after you push up those changes, you can revert and roll back those changes. So at the core of this is it allows you to treat your infrastructure as code. And what this does is it gives you the flexibility to build, change, manage your infrastructure in a really safe and repeatable way. So why is this important? Like, why is building with configuration files better than building in the UI? So firstly, it ensures consistency between environments. So this takes care of that, like, well, hey, it works on my machine. Like you've heard that 100 times. You have this one source of truth, that's this configuration file. So it decreases that phenomenon by a lot. It's also great for onboarding developers. So this happens a lot where you're onboarding a new developer and they're setting up their machine, and you give them this like book, like this huge book of like, okay, like good luck, here you go, this is how you set up your machine, and they're like in the corner crying because like they have no idea what's going on. Versus if you use configuration files, you give them the configuration file, say, hey, deploy this, done. So it's just like a really great way to like spin up everything that you need in like one place, one file, and happy experience for new developers. Another benefit of infrastructure as code is that it eliminates configuration drift. So configuration drift happens when there's changes that happen during incident management. A lot of times you have these differences between your staging environments, your pre-prod environments, and production. And those changes, if there was an incident that you had to make a change, a configuration change for one of those environments, it causes a configuration drift between those environments, because a lot of the times you don't make the same changes between production and staging or pre-prod or whatever. So this using one source of truth, you have one configuration file that you can deploy to staging and pre-prod and all your other environments. It also decreases risk. So provisioning all of your infrastructure by hand is really risky. It requires a lot of manual work. It could be error prone. Like, what if there's only one person at the company who knows exactly how to connect everything and configure everything? What if they leave the company? Like, how are you going to know how they set everything up or what the configurations are? So this really like reduces that risk. Because your infrastructure lives in a code repository, and it's central to everybody. Again, it's this one source of truth that everybody has access to, who you want to have access, and it's visible to your system administrators or your DevOps team or whoever needs that. Okay, so how do we actually implement infrastructure as code? So there's a lot of tools that you can use, and I'm going to talk about a bunch of the tools at the end of this, but right now I'm going to talk about Linode and Terraform. So one of the tools you can use is called Terraform. It's an infrastructure as code tool that you can use for defining both cloud and on-prem resources. And again, you use these configuration files that you can version, reuse, and share them with whoever needs access. And Linode is a cloud computing provider that you can use to make these resources. So this is an example of a configuration file, and configuration files are declarative, which means that they describe the end state of your infrastructure. So with whatever cloud provider you're using, with whatever infrastructure as code tool you're using, when you write resources in your configuration file, you're writing the end state. So I'm not going to say this is how you create this Lambda function. I'm going to say this is what I want. And I don't have to write like step-by-step instructions of like, this is how you create the Lambda function. I'm just saying, this is the Lambda function, these are the configurations, this is the IAM role I want, these are the configurations for that. And then your cloud provider will say, okay, let me make that for you. So you don't have to go into like the details of how to do it. Normally configuration files are simple, they're human readable, and again, they describe the overall topology. And so in this configuration file, once you deploy this, these resources are going to be either created or updated or destroyed, depending on if they exist or not. So really reusable. It's a very reusable process. So specifically in this configuration file, we're saying, hello, please create this IAM role, create this Lambda function. That's it. Thank you. So I don't need to say how to create them. I just write what I want. And then in this case, Terraform will create these resources for me. There is a core workflow for handling infrastructure changes, and there's a version of this with every cloud provider that you use. Like, they all have some sort of, create, update, delete, some kind of workflow. So with Terraform, the first thing we need to do is write the configuration file. This is where you define all the resources that you want to create and all the elements you need. The command you use here is Terraform refresh. So this goes out and it will talk to all of the current cloud providers. It'll say, what is my current state. It'll get that current state for you. Next, we have Terraform plan. So Terraform plan will create an execution plan, and here in this stage, you'll figure out what do you have to do to get your current configuration to your desired configuration. So you're saying, before when you write the configuration file, you're saying this is what I want, and then you're saying what I have versus what I want. So what's the actual state and what's the desired state, and then it's going to do kind of like a git diff and like differentiate, like, okay, I need to add this, I need to remove this, I need to update this. It'll give you like that difference. And so based on what you want, Terraform will create this plan of, okay, I know how to get you to where you want to be. And then we have Terraform apply. So this is when Terraform goes out and performs the proposed operations. It'll execute that plan. It'll actually perform those actions. So it'll add your GCP network, or it'll remove your DynamoDB database, or whatever you want it to do. It'll perform those actions. And there's a couple of parts to this that are essential to the way it works. So the first is core. So core is responsible for a few things. Firstly, it takes in that configuration file. The configuration file is something that you create, that's written by you, the user. It also takes in the current state. Again, that's that source of truth for your environment, and it uses that state file to determine what needs to be created, updated, or destroyed. So when you run all of your commands, you have that one source of truth. And then you have what's called providers. So providers are how Terraform will connect to the rest of the world. And so there's a ton of different providers. You have things like infrastructure as a service tools like AWS, Azure, GCP, Linode. You have platform as a service tools like Heroku and Kubernetes. You can have software as a service tools like Splunk and GitHub. And so you have, what's great about using infrastructure as code, and we'll talk about this a little later when we talk about tooling, but you always have all of these different parts of your infrastructure that are connected to each other, right? Like you have your infrastructure as a service, your platform as a service, and your software as a service, and these are all part of your logical end-to-end delivery. Like you can't have your application without like logging or without GitHub or without all these different pieces. So with infrastructure as code, you have this one place where you can manage all of those different pieces. So when you use infrastructure as code, you have this single unified delivery of, again, all of those pieces. You don't want to have to use like one tool for your infrastructure, one tool for observability, one tool for every service of your application. And you don't have to piece those things together. So instead, anything that has like an API associated with it, Terraform can enable them to be a provider, and so you have this one end-to-end solution. Okay, so how do you actually start using infrastructure as code? Like we're going to go through like from someone who doesn't have any infrastructure existing to someone who already has an entire application existing, and like how do I adopt this into my organization? So first, let's start out with someone from like day one. So I have nothing, I don't have any resources, and I want to start using infrastructure as code. So this is where you go from running nothing to running something. And so this is where you provision your initial set of infrastructure. You describe what's my desired configuration, like what do I want to be connected to what. And so this is where you create your Terraform plan, your execution plan. Again, apply will go out and create or update those resources for you. So then there's the more challenging day 2 and day 2 plus. So this is when you already have something that's existing and you want to update it, or you want to remove something, or you want to somehow evolve what you have. So you're changing this over time, you're adding new services, you have existing infrastructure, and you can enhance it by adding other elements, or you can run, or you can add things, you can remove things, but what's great about this is that you're running the same workflow. So those 3 commands, the Terraform plan, Terraform apply, all of them have that workflow. You can use day 1, day 2, and forward. The workflow doesn't change. And then you have day N, and this can be at any time in the future where you decide to decommission your infrastructure. Let's say I was using this for a test environment and I just wanted to see like what would happen if I create some amount of resources and put them together. So maybe these resources, like you don't need them anymore, you don't need this infrastructure anymore, so you can run Terraform destroy, and that's going to destroy all those resources. And it's basically just a specialized version of apply that will remove those resources and destroy all of those elements. There's a lot of advantages to this workflow. Firstly is that the day 1 experience is identical to day 2. So when you create your infrastructure, you update these configuration files, that process, oh my god, I've touched this thing like 12 times, I'm sorry. The process is not going to change. Like you have this one workflow that you can use to create, update, destroy your resources, and that is not going to change. So your day 1 experience is going to be identical to day 2. And when you think about that, like your infrastructure is continuously evolving, right? Like you're never going to, I don't know about you, but I'm never going to get to a place where I'm like, okay, that's my infrastructure, I'm never touching it again, I'm done. Like you're always going to be adding things, removing things, add a server, add a database. Like it's always going to be evolving, and when you have this one unified place where everything lives, and you know it's in one place, it just will make your life easier. So again, you can destroy this whenever you need to. If you run Terraform destroy, it'll just clean up the environment. Like you don't need like a separate workflow for it. You can use the same workflow. And in this life cycle, you go from nothing to something. You evolve it day over day, and then you can decommission it. So as your team grows, it can be challenging to manage your infrastructure. And so normally companies will start with like one single individual. Like this happens with startups, like there's one DevOps person and they know everything about the infrastructure and nobody else knows what's going on. So this is really common where that specific person, like they will start that configuration file, they'll write everything, then they'll run Terraform plan. What does this configuration do? What does Terraform need to do to apply these changes? They'll run that basic workflow, and that one person will continue to evolve the infrastructure on their own. But now the company is growing. Let's say now you have a DevOps team, or you have a team of system administrators. Like now you have a group of people. So how do you add multiple team members without stepping on each other's toes? So basically, the point here is we want to have a consistent view of what the infrastructure looks like, and we don't want to step on each other's toes. So you do this with something called Terraform Enterprise. And so this augments the workflow a little bit because you're using version control. So you're using something like GitHub or Bitbucket or somewhere to push those changes to, so that, again, you have this one source of truth, but instead of those configuration files living just in one person's land, you have them in GitHub. And then you have something called a Terraform module. So this is good for like really, really big organizations. And a module is basically a black box of a few different resources that are put together. So let's say like I have a group of resources put together, and it's really complex to make, and the configuration file for it is like really long, and as a developer, I might not necessarily need to know all of the details of every configuration for this group of resources. I might just need to be able to create that resource when I need to. And so this is a way to encapsulate that complexity and have those resources be accessible to a broader audience. So modules are basically containers for multiple resources that are used together rather than directly in terms of like physical objects. So it's good for like groups of resources. So how do we manage and share these modules? So there's a few different registries for cloud providers. In this case, again, we're talking about Terraform, but PowerShell has one, AWS has one, Google has one. Who's the other one? Those are the big ones. Azure has one, specifically PowerShell. Yeah, so all the big cloud providers have their own registries, but what's great about a registry is that you don't have to start from scratch. So let's say you want to create a Lambda function. You'll go into the Terraform, and you're using Terraform. So you can go into the Terraform registry. I swear I'm not touching this, and it's just like freaking out. If you wanted to create a Lambda function, you'll go into the registry, type in Lambda function, and there'll already be a template there for you that you can use. Same thing with like a GCP network. Let's say you want to create a network. You'll go in, you'll write that out in the registry, search for it in the registry, and there'll already be pre-written code for you that you literally just copy and paste. And in the demo I'll show you, that's kind of the same thing that we did. So my point here is that you don't have to start from scratch. You can use existing code that lives in whatever registry you're using, and so it just makes that process a little bit easier. You can also import your existing infrastructure into a configuration file. So basically, there's like a new process, right? So in our original workflow, you're starting from scratch, but like, what if you already have resources? Like, what if you already have a ton of infrastructure in place? Like, what do you do? Basically, there's a new process. So first, you identify the existing infrastructure that needs to be imported, and then you import that infrastructure into your Terraform state file, and then you write a configuration file that matches that infrastructure. You review the Terraform plan, and then again, it's the same process. You apply those changes to your application, and that'll just update the state. Another benefit of using infrastructure as code, a lot of them do this. It's called multi-cloud deployment. It's very rare that I think that companies are using just one cloud provider. Like, okay, raise your hand if you use more than one cloud provider. Yeah, this is like, it's like almost everyone. So I recommend using an infrastructure as code tool that can do multi-cloud deployment because it's really rare that companies will only use one cloud provider. And so this is great for like fault tolerance. There's a more graceful recovery if something goes wrong, if one cloud provider has an outage. And so with Terraform, you have that same workflow, and you can manage multiple providers. You can manage multiple resources. You can have like these cross-cloud dependencies, and you can handle them all in one place. Okay, so let's recap the advantages of infrastructure as code, and then we'll do a quick demo. So infrastructure as code enables everybody, regardless of your DevOps experience, to be able to self-service their infrastructure. So if I'm a developer and I need to work on specific resources, I can create those on my own, or I can go in and have someone create a module for me. So it makes the self-service process of your infrastructure really great. You can also implement the principle of least privilege. Like if you're the DevOps person and you don't want everybody to have access to be able to create every type of resource, like you have that ability to have that control. You have this natural progression from day one, where you start from nothing, to day 2+, where you have that core IAC workflow, and then you have this natural progression from single person to a small team to an entire organization, using things like enterprise and modules. And you can also do multi-cloud deployments. You can I did that in the wrong order. You can import your existing infrastructure, and you have this single unified delivery of your infrastructure as a service tools, your platform as a service tools, and your software as a service tools. Okay, this is my favorite slide. So when we're talking about infrastructure as code tools, there's so many different tools out there. And there's a bunch of different options. So we talked about Terraform a little bit, and the key differentiator between Terraform and the other tools is that Terraform allows you to deploy resources from all of the other cloud providers. So you can deploy a database with GCP, an instance from Linode, all in the same configuration file. Terraform has a registry that has these like pre-made modules you can use. Amazon has two infrastructure as code tools. The first one is CloudFormation, and the second one is SAM. So CloudFormation is for non-serverless resources, so things like EC2, RDS, and then there's the serverless application model, SAM. So SAM is for serverless resources, so things like Lambda and DynamoDB. And so one of the big differences between Terraform and CloudFormation is that with CloudFormation, you have to use Amazon resources. So if your entire infrastructure is built on Amazon, you can use CloudFormation. But if you have resources from other cloud providers and you want to have that in your infrastructure as code tool, you can't use CloudFormation. What else? So with what else? Terraform is written in a specific language. It's called HashiCorp configuration language. It's like specific to HashiCorp. With Amazon, you have either JSON or YAML. Google is another cloud provider that you can use. They also have templates that you can use online. They also pair on their documentation. They have a ton of resources that you can use, GCP resources with Terraform. So I think that's their preferred method of infrastructure as code, is to use those together. There's also PowerShell desired state configuration, where you can install modules with DSC, desired state configuration, with those resources. And the registry for PowerShell, that I'll share these links at the end, but the registry is PowerShellGallery.com. And so this is that central repository. So if you wanted to use resources and create them with PowerShell, you have that ability with the PowerShell Gallery. And so what's great about this too is that you can also, with PowerShell, add resources from other cloud providers. So that's not a constraint here. So just to summarize, like some things to think about when you're choosing an infrastructure as code tool. Are you using resources specific to one cloud provider or more cloud providers? Like, do you need external resources as well? And do you want your configuration file written in YAML or JSON or HashiCorp configuration language or in a PowerShell script? So what I want you to take away from this is that it doesn't matter what tool you use. Like, using infrastructure as code is going to help you with automation. It's going to help you with reusing templates. It's going to speed up your development process. So you have to choose the tool that's best for you and that meets your requirements. But the point of this I want to make is, like, it doesn't matter what tool you use. It just, to use infrastructure as code is kind of the meat of this. Okay, so let's do a quick demo with Linode and Terraform. Also, the reason I keep bringing up Linode, I probably should have mentioned this. I work for Akamai. Akamai owns Linode, so full disclosure, that's why we're doing this demo. Okay, so one of the providers that Terraform has is the Linode provider, and I'm gonna have I'll have a QR code at the end of this that has a link to this demo, so you don't have to like write anything down or take pictures, unless you want to. Okay, so there's two prerequisites. You need a Linode account and you have to install Terraform. The first thing you have to do is generate an SSH key. This is how you connect to your server, and you use this command, SSH Key Gen, and then you choose where to save it and create a passphrase. And then you copy it and save it. You enter cat in the path key, you copy it and save it. Next, you need to create a Linode API token, and you do this from the Linode UI. And you choose create a personal access token, and then you choose your level of security. So it's basically just the access levels that you want. Once you create this, you have to save it locally because you won't be able to access it later. Next, you're actually going to create your configuration file. So this is everything that we just went through. And you're going to save this as a TF file. The easiest way I know how to do this is to just do like nano and then the name of the file. And this is how Terraform knows what to look at. It's with that .tf file. And again, this is where you define all the resources that you want to create. So this template is from the Terraform Registry. All I did was copy and paste it, and I have to copy my Linode API token here. If I was using PowerShell, or if I was using Google or whatever, I would have to add that API token. So this is just specific for Linode because I'm using Linode resources. You add the passphrase that you just created, and yeah, this is your configuration file. The first thing we do is run Terraform init. It's just going to initialize Terraform. And then we run Terraform plan. And once you run plan, it basically gives you an execution plan of like, this is your configuration file, and it'll say, okay, this is what you want to do, right? Like this is what you want to create, this is what you want to update, or this is what you want to destroy. In this case, I'm adding these two resources. And then you run Terraform apply, and this will actually go ahead and apply those changes. It'll create, update, or destroy whatever you want. And you can see here, apply was complete. I added this resource, and it'll do whatever you specified. And then in the UI, you can see like Terraform web example, like that instance was created. This is the QR code for this full tutorial. So this one is for Linode and Terraform, but I'm going to, in the next slide, post the PowerShell gallery link so you guys can copy that if you would like. So there's a ton of different ways to learn how to use infrastructure as code. The first thing I would recommend is figure out which tool you'd like to use, and all of them have like resources online. The one at the bottom is for PowerShell that I talked about. There's the GCP and Terraform documentation together. Like when you go on the Google infrastructure as code site, they use Terraform, so that's an option you can use. If you're using AWS, there's something called let's see if I remember, the serverless resource. I'm going to find it. I worked on it. It's the same registry that everyone else has, but it's for Amazon. And yeah, this is our DevOps community at Linode, where you can check out our blogs. And that's all I have. Thank you, everybody.